Did you know that if you try to control an AC motor's speed by just reducing the voltage, you could burn it out in no time? That's right. Without the right method, motors can overheat, lose torque, or even stall completely. But here's the catch. Modern variable frequency drives VFDs don't simply lower voltage. Instead, they use a technique called Pulse-Width Modulation, PWM, to control speed with precision and efficiency. So why is PWM so important? And why is direct voltage regulation not a good idea? Stick with me, and by the end of this video, you'll understand exactly why PWM is the gold standard for motor control. Let's say you want to slow down an AC motor. One way to do this is by reducing the voltage directly. But here's the problem. Lowering voltage also reduces the magnetic field inside the motor. And what happens when you weaken the magnetic field? You lose torque due to this formula. In an AC motor, the torque, T, is generated by the interaction between the stator magnetic field, F, and the rotor current, I, as per this formula T, KFI. If voltage decreases, then magnetic flux, F, also decreases. That's why torque output drops. Inefficiency and overheating. Reduced voltage increases electrical resistance, causing excess heat, as we have seen for ceiling fan regulators of resistance type, which controls fan speed by stepping in and out resistance in series. It might slow down, but it will also start vibrating, humming, and struggling to run smoothly. Motor instability. The motor might stall or run unpredictably. These reasons clearly show that direct voltage control is not an effective way to regulate motor speed. So, what's the better solution? That's where pulse-width modulation, PWM, comes in. PWM is a technique that controls the average voltage sent to the motor by switching the power on and off through IGBT at very high frequencies, typically in the range of 2 kHz to 20 kHz. Think of it like a flashlight. If you turn it on and off very quickly, your eyes don't see the flicker. Instead, you see a dimmer light. Similarly, PWM sends rapid pulses of full voltage, controlling how much power the motor receives without lowering efficiency. PWM basically modulates the width of voltage pulses while keeping the peak voltage constant. By adjusting the duty cycle, the percentage of time the signal is on versus off in one cycle, here is the formula. V average, V peak, x duty cycle, where V average, mean our effective voltage sent to the motor, V peak, Y maximum supply voltage, 230 volt or 460 volt. Duty cycle is percentage of time. The pulse remains on during one cycle. As we discussed, instead of supplying a continuous analog voltage, the VFD switches the power on and off thousands of times per second, typically in the range of 2 kHz to 20 kHz. At these high frequencies, the motor averages out the rapid switching, effectively seeing a smooth voltage similar to a sine wave. If the PWM signal has a 50% duty cycle, the motor receives power half the time and sees an average voltage of 50% of the peak voltage. If the duty cycle increases to 75%, the average voltage rises to 75% of the peak voltage. Now comes how PWM generates a sinusoidal-like voltage waveform. VFDs use three-phase PWM to create a near-sinusoidal voltage waveform from a DC source. The on-off pulses are timed strategically to simulate a smooth AC sine wave using pulse amplitude modulation, PAM, and PWM carrier frequency techniques. The motor inductance filters out the high-frequency switching, leaving a smoother sine wave-like current flow. At low speeds, the pulses are narrow, that is low duty cycle, reducing the effective voltage. At high speeds, the pulses are wider, that is high duty cycle, increasing the effective voltage. Result: the motor operates efficiently at different speeds without overheating or torque loss. Did this video help you understand why PWM is essential for VFDs? Let me know in the comments if you've ever faced motor issues due to improper speed control. And don't forget to like, subscribe, and hit the bell icon for more expert insights on motor control and automation. Thanks for watching, and see you in the next video.